going to be looking at applications with lines, so we need a little bit of an introduction here. In many day-to-day applications, two variables are related linearly. By finding the equation of a line, we produce a model that relates the two variables. There are three models that I'd like us to focus on. So the first one is a linear cost function model. And this looks at the cost defined as C of X to produce X items. So C of X, C is the name of our function, X is the number of items, C of X is our cost function. M times X is the variable cost per item. So is the variable cost per, or meaning for each item. B is the fixed cost, and we'll see an example of that in a little while. Sometimes when we pay for something, it costs us a certain amount no matter how much we produce or do. So a linear revenue function models the revenue or income, how much money I'm making for selling X items. So P times X represents the price per item for each item and so we're looking at the price times the number of items sold. So we want to make money, but as we saw up above, it also costs us to produce these goods. And so our profit is actually the amount of money we're making after we pay for the costs. So in order to find this, we're going to subtract the cost to produce or make X items from the revenue or income for selling X items. So it costs us money to make goods. We want to sell those goods. That's our revenue. And then the profit is whatever revenue minus the cost to make these goods is. So for example, at a summer art show, a vendor sells lemonade for $2 per cup. So I want you to think about that, $2 per cup. Is that what it is costing this vendor, or is this what the vendor is actually making? So this is what the vendor is making. That's what he's selling it for. But he doesn't just sell it, he actually has to make it. And then he's going to a show. So he's setting up a booth, and the booth costs $120 to rent. And this vendor knows that the lemons, sugar, and the cups cost a total of 50 cents for each cup of lemonade produced. So we can use this information to write a linear cost function to produce X cups of lemonade. And so the fixed cost is the thing that doesn't change no matter how much lemonade I make or sell. So the fixed cost is the $120 to rent the booth. It's going to cost him $120 whether he or she sells any lemonade at all. So $120 to rent the booth. The variable cost, remember variable means to change. So the variable cost is the 50 cents. Not that the 50 cents is changing, but it changes in a total amount because it's 50 cents for each cup. So our cost function is a combination of the fixed cost and the variable cost. The name of our cost function is C of X, which is equal to our fixed cost plus our variable cost. And our variable cost is 50 cents. Notice the decimal indicates a partial dollar, so 50 cents of a dollar. But that is for each cup, and each cup is represented by X. Now another way we could write this, it does not matter, is C of X is equal to 0.50 times X plus 120, because addition is commutative. We can write it either way. So your job is to write a linear function. So I'm going to start you out. And you're going to have to choose which one is the correct linear function. A parking garage charges a flat fee of $2 plus $1.50 per hour. And write a linear function to model the cost for parking T hours. And I made a little bit of a mistake there. Did you notice I asked you to write it for T hours? So that means our input is T, not C of X, but C of T.